Everybody, welcome back to another fun and exciting pre-algebra class. Today we are going to be in Chapter 6, Lesson 5. You can find that on page 258, page 258. What we'll be talking about today is the surface area of cylinders and spheres. So continuing on talking about surface area from last lesson, we talked, remember, about rectangular solids, cubes, and then triangular prisms as well. So what you should be doing is you should just be, accumulating a bunch of formulas and hopefully a little bit of an understanding. We've been talking about the nets and kind of what it looks like when you unfold it. And so you should have a little bit of understanding about why the formula is the way it is. So yeah, you should be just compiling a list. When it comes time for quizzes and tests, you should just be able to look back at that list, get your formula, get your idea of how to solve the surface area or area of the different shapes that we've already talked about. And yeah, that's what you should be doing. So you should be keeping up with it, memorizing it. Don't just expect that you're going to get to a quiz or a test and you're going to be like, oh yeah, I already know this. Well, if you haven't been paying attention, if you haven't been writing it down, then there's a good chance that you probably don't know it when you get to your quiz or test. So write these formulas down. Very important. All right, look down here. Today we are going to be doing the cylinder and the sphere, but we're going to start with the cylinder. So here we go. This shape here, the yellow shape, I drew a cylinder. It's not a perfect cylinder, but it looks pretty good for, just a little drawing on my tablet. So it turned out pretty good. I'm happy with that. Not always do my drawings turn out well, so I'm kind of proud of myself right there. So, and then here on the right, what you see is the net. In other words, we took the top, and kind of flipped the top up. We took the bottom, flipped the bottom down, and then we unrolled it, okay? And so what you end up with is you end up with a circle, okay? That's this circle. And then you end up with another circle here on the bottom, and that's this one on the bottom. And then you end up with this rectangle, and this is that piece right there. All right, so when we do that, we should be able to see some things. And what I want to show you is when you're finding the surface area, there's two parts to the surface area. And let's take them one at a time. Let's take the second part first. What is that? 2 pi r squared. Well, if you remember, the area of a circle is pi r squared, right? So if we add a 2, what do you think we're doing? We're doing these circles right here, okay? So that's the two circles. 2 pi r squared is going to give you both of those two circles right there. Now, this one is a little bit more complicated. But if you notice, we have a rectangle, and the rectangle was BH, right? Area equals BH. So you probably would guess that this is the height, and you're correct, all right? So that's the height of the shape right there. But typically, when we measure these, we don't have a width or a length necessarily. All we have is, kind of the distance around. And it's really hard to measure the distance around something, right? That's why mathematicians developed pi, is so that we can measure the distance around something. So here's what this is. This measurement right here in this rectangle here is actually 2 pi r. 2 pi r. And so if you remember what 2 pi r is, it's your circumference around the circle. So we have two parts to this. We have the first part that we talked about was actually the surface area of the top and the bottom of the cylinder. Okay, so that's this piece and this piece. And then the second piece here, I'll put this in this green color, is the actual rectangle itself. And so that would be, this part of the cylinder, and then, over here in the net, it would be this part. Okay, so let's go ahead and do one of these. Let's try one of these. Let's put some figures on here. Let's put some numbers on here, and we'll see how you do. All right, let's say that, in fact, let's just do the one that's in the book on page 258. They say that this radius up here is 3 inches. All right, and then they say that this, actually it's centimeters, so I'll do it just like the book has it, centimeters. And then this height right here is 5 centimeters. And I know my drawing doesn't look right because that's more, it's not proportional, but we're just going to go with that, and we're just going to work it with these numbers. So now what we would do is we're just going to plug into this formula where these different things go. Where height goes, we're going to put 5, and where radius goes, we're going to put 3. So let's go ahead and do it. So we'll put 2 times pi, 3.14, remember that's the number that we're going to use, times r, which is radius. There's the radius right there, 3 times the height, which is 5. Now we kind of want to put that in parentheses right here because that's the first part. Then the second part is 2 pi r squared. So the second part is going to be 2, we'll put this in parentheses as well, times 3.14 again, times 3 squared. And we'll put that all in parentheses. Now what you do is you just work it out. You just go through it and you know, you solve this, and then you solve this, and then you add it together. So when we go ahead and we multiply 2 times pi, 3.14, times 3 times 5, you can do that on your calculator. I'll just bring my calculator right up here and we can do it. So 2 times 3.14 times 3 times 5 equals 94.2 over here, 94.2, and that's going to be plus whatever we get over here. So again, follow order of operation. We're going to want to do that first. So we're going to get 9 there. 3 squared is 9. So we have 2 times 3.14 times 9 equals 56.52. And then we would just add those two together. So 56.52 plus 94.2 equals 150.72. 150.72. And that is going to be centimeters squared, because remember, we're in surface area, so centimeters squared. Or you could say square centimeters, that is the same thing. So there is the answer to the surface area of that cylinder. Now let's talk about the lateral surface area. Remember what that is from last lesson. That's the surface area without the top and the bottom. So we got to get rid of these two circles. Remember what, and this is why this is kind of important for you to really kind of understand the concept about with the nets and with the idea of, okay, what is this formula actually doing? What we want to do is we want to get rid of that 2 pi r squared, because that was the circles, right? That's the part that we want to get rid of. So if we do this, we just want to get rid of this second part, so then you don't actually add it to anything. And so this was the surface area. I'm going to write surface area equals, and then we had the lateral surface area, LSA, the lateral surface area, or you could just say LA, lateral area. Either way, is 94.2. 94.2, and again, that is centimeters squared. That's the easiest way to kind of tell you how to do it if you want to find the lateral surface area. If you don't need to find the surface area, then all you need to do is plug it into that. If you have to find the surface area and the lateral surface area, then just find the surface area first, and then this first number that you get is going to be your lateral surface area. Okay? And you can see that again in your book there on page 258. If you have any questions, you can just kind of look down there. All right, the next thing that we want to talk about in this lesson is the sphere. And this is pretty cool, right? This kind of looks like the moon right here, or I don't know what, maybe a cue ball, kind of like my head, maybe. I don't know what it looks like. Maybe a marble. I don't know. But I think it looks like the moon. So we're going to call that the moon. The moon is a sphere. The Earth is a sphere. A volleyball is a sphere. A cue ball is a sphere. My head isn't quite a sphere, but it's pretty close. Uh, so how are we going to do this one? What is this? Now, I don't show you the net on this one because, to be honest, there is a net and there's kind of not really a net. Because the way this net is, it almost looks like this, and it's really hard to kind of to show it. It's just kind of a really weird net. You can look it up if you want to, but I don't think it's really useful here. What's really useful is this formula right here. And so if you will memorize that formula, plug it in, you'll get the right answer. So in your book on page 258, the example, they say that it is 5-inch. So we're going to go right here. Let me change the color so you can see it a little bit better. They say that this is a 5-inch radius right here. So 5 inches. Okay. All right. So 5 inches is a radius. And notice that's the only thing we need. We just need radius right there because we already know what the 4 is. We already know what the pi is. We already know that it's squared. The only thing we're missing in this formula is the radius. So we're just going to take 5, plug it in there, and figure it out. So 4 times 3.14 times, I'm just going to do it in my head, and you can do it in your head if you want to right there. 5 squared is 25. 5 times 5 equals 25. And then just come back to your calculator. Let's clear this out from that last problem. 4 times 3.14 times 25 equals 314 would be our answer. 314, and these were inches. I think those were inches. Yes, inches in your book as well. Inches squared. Now, interesting. Notice that it basically came up to pi, right? We just moved the decimal point. Why did that happen? How did that happen? Because really, we did 4 times 25. What is 4 times 25? It's 100, and then we had 100 times 3.14, 2 zeros, just move the decimal point 2 places, 314. You could have done it like that, and maybe you did it like that, and you're like, why is this guy using his calculator? Like, this is not a calculator problem. I know, but I use my calculator to show it to you the other way. I figured that this way might be a little bit complicated for you the first time, but you can do that. If you ever get something to add up to 10 or add up to 100 or 1,000, then you can just move your decimal place, and that becomes just a little bit easier. Okay, well, that's all I have for you in this lesson. You're like, yes, finally a short lesson. I know, you're welcome. And so work hard on this. Practice these. I guess the biggest trick here is just making sure that you know what you're looking at. Make sure you know you're looking at a sphere. Make sure you know if you're looking at a cylinder. Make sure you know what the radius is. And with the cylinder, make sure that you know also what the height is, and then just plug it all in, and you should be able to get the correct answer. Remember, we're using pi equals 3.14. Don't use the pi key on a calculator yet. We'll get to that later on in other classes, but for this class, use 3.14. Okay, that's all I got for you. We'll see you later. Have a good one. Bye-bye.